Are you ready for a crash course in color? How about the relationship between color and light? What is light? Have you ever heard of additive versus subtractive color? Light is made up of packets of energy called photons. These photons travel in waveform to reach objects and your eyes. In 1666, Isaac Newton discovered that white light contains the full spectrum of colors. Part of the human visual system includes photoreceptor cells that are both rod-shaped and cone-shaped that line the back of your eye. The rods are responsible for sensing changes in brightness, such as lights or darks in the world, and cones are sensitive to color. We have 3 types of cones. One is most sensitive to red, one for green, and one for blue. With white light containing all the colors of the spectrum, this means that all 3 of our cones are stimulated when viewing it. Diving into the world of technology and man-made light, white light coming out of a screen is also going to be the combination of red, green, and blue light. When zooming in on a television, we can see that each pixel is actually made of red, green, and blue subpixels that combine to create all the colors. All of this so far is what we call additive color. We add red, green, and blue together to create white. We use cathode ray tubes or liquid crystals in displays to produce reactions that create light. Or in the case of a tungsten light bulb, we heat up a piece of metal filament to create light. Ever notice the inside of your toaster glowing? Now, for the world of subtractive color, we are thinking paint or ink. I know you love watching those paint videos where they start off with white and keep adding the primaries to achieve every other color. The primary colors of subtractive systems are actually cyan, magenta, and yellow. Think of your CMYK printer. Cyan, magenta, and yellow are complementary to red, green, and blue. If you are seeing a bright green wall, that means the paint is actually absorbing the red and blue light and only reflecting the green back to the cones in your eye. A white wall would be reflecting all of the colors back to your eye, and a black wall would be absorbing them all, no color. This is why you become warmer if you are wearing all black out in the sun on a summer day. The black is absorbing the light, and remember, light is energy. Photons are energy. This energy can turn into warmth. And thinking back to our toasters, the metal gets warm while also producing light to toast our bread. And now we know that without light, there is no color. And there is no color without the cones in the back of our eyes. So, if a tree falls in the forest and no one was there to perceive it, did it have color?